My name is Daniel Herrera. I work for Polis, and today we are presenting eHUBS research results, this time from the Newcastle University. So we will have 3 presentations, but before we will have Dylan Disanayake, who is the coordinator of this research group at the Newcastle University, who will be explaining us the relationship between these 3 different research related to eHUBS. So first we'll have Dr. Gustav Bosehans, who will be speaking about identifying the target groups for behavioral change before and after the implementation of eHUBS. Afterwards, we will have Dr. Zhang who will be speaking about the results of emissions modeling for all the eHUBS cities. And afterwards, finally, we will have Matthew Burke, a PhD student, who will discuss the target groups for future eHUBS in the region of Manchester. So the dynamics of the session will be that we will have the 3 presentations, and afterwards we will invite the speakers to come to the stage, and they will engage in a conversation. So you will have time while they present to write down your questions, and we'll bring them together at the end so they can discuss and engage with you, with the audience. So I would like to welcome to the stage to Dr. Dylan Disanayake, who will discuss further.
Good afternoon. It's really nice to see many of you here, and it's a chance for us to present the very interesting research we have conducted in the last 3 years from Newcastle University. And I am Dylan Disanayake, and I am a senior lecturer in transport modeling in the university. And I thought before we have the presentation to give you a little bit of a story behind those and how these presentations connected to each other, so you will get most out of this presentation. So the first one is Dr. Gus Bosehans is here presenting about the behavioral change, particularly focusing on Amsterdam City. And because we have only 10 minutes presentation, so we can't cover everything, but we have lots of research publications coming. So this is a sort of signposting some research coming from Amsterdam City. And then we have Leila Zhang joining us by Zoom, online. And Leila will explain about all cities, how the emissions calculations related to eHUBS and how emissions can be saved by this new eHUBS concept. So finally, my PhD student Matt Burke is here to show you which areas in the region in Manchester what we have to target for new eHUBS according to our research publications already published last December. So the eHUBS publication is a basis for Matt's presentation. So hopefully you will enjoy the 3 presentations, and we will have a good discussion later on. Thank you.
Can I start? Well, hello everyone. I have the honors to hold the first presentation today. My name is Gustav Bosehans, or in short Gus, and I've been working on the eHUBS project for almost 3 years. And yeah, today I will share with you some of the findings that we discovered as part of our research. I have to say also that by training, I'm actually a psychologist, environmental psychologist, I'd say. And I'm based at the School of Engineering, so a bit of an intruder. So I'm focusing mainly on the behavioral side of things. Now, just before I go into the findings, I'll just give you a quick overview of what I will cover in my presentation. So first of all, I will just give you a quick definition of what we in our research group define as an eHUB. And then I will go on to identify potential target groups for behavioral change. And most of this discussion will be based on the publication that we published half a year ago, last year in December to be exact, on identifying target groups, which is freely accessible online as well. And in the second part, I will talk about some newer findings from a user survey, and this will also include comparing actual and intended use of shared mobility. Now, in our definition of a mobility hub, we assume that a hub has at least two different types of shared electric vehicle. The reason is, if you have just one type of shared electric vehicle, then it's not distinguishable from a normal sharing service such as e-bike sharing, scooter sharing, etc. So the idea is that really eHUBs is about having a variety of modes at your disposal. And for instance, this could be any combination of, for instance, shared e-bikes, cargo bikes, e-scooters, or e-cars. Now, one of the very first things that we did as part of the eHUBs project was identifying potential users. And I think Boris is posing here with an e-bike. I think he's probably never sat on one, but he has been posing for one. So one of the key questions, of course, who do we, as policymakers, cities, researchers, who do we want to use shared mobility hubs? Here's just to give you an example of how shared mobility hub can look like, just having a few modes bundled together. Well, and the answer is quite simple. We want everyone to use eHUBs, but especially frequent car users, because obviously they are where the emission savings can be made. But then, of course, there's the question, who does actually want to use eHUBs, and does that combine with who we want to use them? So to find out about potential target groups, we conducted a big survey in the 7 pilot cities of the eHUBs project. And we administered this survey back in 2020. And the survey covered a range of attitudinal statements, demographics, questions about people's general travel behavior and shared mobility use. And the main target of the survey was to identify target groups, but also to estimate potential mode shift and emission savings. Well, sadly, when we implemented the survey, it was literally just when the first lockdown came into place in 2020. So that, of course, wasn't ideal timing by any means. But we still managed to get a fairly good turnout for the survey. And so you can see we had almost 2,500 responses across the 7 cities. And the survey was administered either by the cities themselves, or in the case of the 2 largest cities of Amsterdam and Manchester, we used online panels to get the data quicker. Now, I'm going to spare you most of the details of the method, but what we used to identify target groups was what is called attitudinal market segmentation. Some of you may be familiar with that method. Essentially, what it entails is you present people with a series of attitudinal statements. In this case, we had statements towards the environment, shared mobility, and car use, amongst others. And people rate those statements on a scale from strongly agree to strongly disagree. And based on these statements, so we first factor analyzed them to reduce them into a smaller number of factors. And based on these factors, we distinguished different groups. So within each group, people have similar attitudes. And as you can see on the graph on the right side, so this is our actual clusters that we had in the end. So each point, in essence, represents one respondent, and you can see that they're all very distributed in space. So they have different anchors with different attitudinal dimensions. So within itself, the clusters are very similar, but they are very distinct from the other clusters. Now we did this analysis for Amsterdam. So the results I'm presenting here are for Amsterdam respondents. And the first cluster that we identified, which was also by far the largest cluster, so we had a sample of about 500 respondents, and the first cluster represented almost 70% of those. And this cluster was mostly composed of car-dependent families. So most of them were younger. They tended to be younger, between 18 to 44 years. They also tended to, more than half of the households also had children in the household. They had high levels of car ownership, and they were interested in using both, especially in e-cars and e-bikes. The second largest cluster is what we call multimodal mass-ready people. So they also tend to be younger, they cycle a lot, they tend to have a pro-environmental attitude, and they had a very high intention to use electric cars. The third cluster was a bit smaller, what we call the anti-mass individuals. So a lot of those people in this cluster were older. They had no children in the household. There were half of them were also not working or employed, and they were by far the least inclined to use shared vehicles. However, it has also to be said that they were actually the most satisfied with the way they currently travel, and a lot of them were using their cars. So you can imagine there were a lot of older people using their private cars and not really wanting to try any other modes. And finally, we had one more cluster, which is quite small, so it's not really reliable in terms of findings, but I think we're still onto something here. In this cluster, there also tended to be older people. Again, no children in the household, and many of them also were not working or employed. They're also less inclined to use shared vehicles, but not as much as the previous cluster. But perhaps more strikingly, of all the clusters, they were the least satisfied with their current travel. So this suggests a bit of mode captivity. So maybe people older people who don't have a lot of mobility options, and who might actually benefit from using shared mobility, such as eHUBs. This is all I wanted to share with you about target groups, and I'm moving now on to share some newer findings about actual shared mobility users and mode substitution. So for this, we also conducted a survey, which we distributed between September last year and until early January this year. Again, in the survey, we covered various dimensions, including attitudes, demographics, shared mobility, intentions, and use. And in the end, we had, in the sample, we had 247 shared mobility users and also a large proportion of non-users. So in this survey, we asked not only users, but non-users as well. We primarily wanted to explore attitudes, mode shift, and also see whether this might have resulted in any emission saving, which Leila is going to cover later on. And again, the survey was distributed primarily via the cities with help of the shared mobility providers, and in some instances, again, with online panels. Now, something that I wanted to show you beforehand is just a few comparisons between shared mobility users and non-users. And you can see a very striking difference. What we know from providers as well, that shared mobility users tend to be younger. In our sample, there also were more of them were highly educated. We also had a lot of more retired people in our non-user sample. If we are looking at a general car use or private motorized transport use, you can see that there was a higher proportion of users said they're never using private motorized transport, and the lower proportion they said they were using it on 1 to 2 days per week. Again, another big difference was seen in public transport usage. So the shared mobility users are also using a lot more public transport. So this is 54% were using public transport on at least 1 to 2 days per week. And a similar big difference was found for ride-hailing as well. So shared mobility users in general seem to be more multimodal. One interesting thing is that we ask both users and non-users for what trip purpose they would use different shared mobility types. And you can see that if you compare all the different bins, there's not a big difference between what users say they're using shared vehicles for and what non-users say they're intending to use shared vehicles for, which is actually a good sign because it gives us a good idea of what behavioral change we can achieve in which areas. And last but not least, of course, one of the big questions we have is, do eHUBs or does shared mobility in general reduce car use? No, we didn't have a massive sample of shared mobility users, so we only had 247 people. which, however, for statistical purposes is sufficient. And what we really want to focus on is this last column, which is telling us which modes were being substituted. And you can see in this column that actually the majority of substituted trips were by public transport, followed by the private car, and followed by cycling. So that sends an important message, because it shows that shared mobility really is not only a substitute for cars, but also a substitute in already sustainable modes, such as cycling or public transport. And if you look at the car users in particular, what kind of alternative modes they used, you will see that a lot of them were either using shared cars or shared electric cars to replace their private cars. So there wasn't an actual mode shift in the terms of transport mode, but just like replacing their own private vehicle for a shared one. So to summarize, what we can conclude from our findings so far is that Mars-ready individuals, our second cluster, they don't really need any convincing to use shared mobility hubs. They're going to use them anyway. They're very open to shared mobility, new shared mobility services. And our primary target group for behavior change seem to be car-dependent families. So if car use reduction is intended, then really efforts should be focused on this group. We also saw that there were some older people who tend to have fewer transport options, and they might benefit from shared mobility, but they are very cautious and very skeptic about its use. So they might need a lot of encouragement and convincing. We also saw that the actual and intended use of shared vehicles is pretty similar for non-users and users. And last but not least, we also saw that shared vehicles are just as likely to replace trips by public transport and cycling as private car use. And yeah, I hope you have learned something new or something interesting. And of course, if you have any questions, you can always send me a message afterwards as well. Thanks for your attention.
Thank you, Gustav, for such an interesting presentation. So questions, write them down. We'll take them at the end. In the meantime, I would like to invite to the stage Dr. Zhang, so virtually, because she'll be presenting virtually. So I guess she should be appearing behind. Yeah. Yes. There she is. The floor is yours.
Yeah, hi everyone. My name is Zhang, and you can call me Leila. And I'm a researcher student, a researcher associate of Newcastle University. Unfortunately, I can only present online. So could you please show my slides, please? Yeah. So today, my presentation will focus on to explore the impact of shared mobility services on carbon emissions across all eHUB cities. Here's the overview of my presentation today. So firstly, I think I will give a structure of our proposed carbon emission modeling, and then I will focus on the layout of questionnaire survey 1 and survey 2, followed by some preliminary results of QS1 analyze and the QS2 analyze. And then I will focus on the emission change after adopting eHUBs. And finally, I will give us some basic idea of Manchester case study. Next, please. Yeah. Here is my the structure of proposed carbon emission modeling. After we got the survey data, we had the vehicle characteristics, and we're gonna calculate the tailpipe emissions and indirect emissions. For tailpipe emissions, we're gonna using DEFRA emission factor to calculate for petrol, diesel car, and the plug-in hybrid car. And for electric cars, we're going to calculate indirect emissions using the left-hand figures. After we got the emission factors of all types of vehicle, we're going to combine the trip database to calculate annual emissions by multiplying average annual mileage and the short journey emissions using the vehicle kilometer traveled and the frequency traveled. Next, please. Yeah, here is the layout of questionnaire survey 1 and 2. I think Gus already gave an overview of these two surveys. So for the QS1, we are interested to investigate the effects of intention to use shared mobility service on both short journey emission and annual emission across all eHUB cities. Well, for QS2, we are interested to investigate effects of use shared mobility services on short journey and annual emissions for all cities. And also for user data, we are going to calculate how the emission change due to adoption of eHUBs. Next, please. So here's a basic result of QS1 analysis focusing on the short journey emissions. So as we can see for QS1, and results found that for most eHUB cities, car drivers who intention to use shared mobility service still produce a higher amount of short journey emissions than participants who are not interested to use shared mobility services. And also we found similar results for annual emissions as well, and which is showing to the next slide, please. Yeah, here's annual emission. In overall, there's for users, for participants who are interested to use shared mobility services, still generated higher annual emissions compared to participants who are not interested to use shared mobility services. But there's an opposite trend for city of Amsterdam, Nijmegen, and Zhang, which participants with interest in use shared mobility services, such as shared bag, shared car in Nijmegen, shared e-scooters in Amsterdam, and Zhang produce less annual emissions than participants who are not interested to use shared mobilities. So as the potential users, they may face some barriers to stop them to use shared mobility, such as the location of a shared vehicle, availability of shared mobilities, price, safety, or effort requirement. So we're thinking if the shared mobility providers could help this potential user to overcome these barriers, they may potentially switch their regularly car trips to shared alternatives. So these potential users, the car-related emissions could potentially be reduced. So next slide, please. So here's the results of QS2 analysis. So for user survey QS2, we found that for city of Aachen, Kempten, and Nijmegen, shared mobility users produce less short journey emissions compared to non-users. While for city of Amsterdam, Leuven, and Manchester, users produce a higher amount of short journey emissions compared to non-users. Well, for annual emission, which is showing the next slide, please. So for annual emission, we found for all eHUB cities except Aachen, users produce less annual emission compared to non-users. So shared mobility could help reduce the car user frequency and the individual's annual kilometer traveled. This all can potentially reduce car-related emissions. So next slide, please. So here's how we calculate the emission change after adopting eHUBs. In this calculation, we're going to focus on the individual car emission saving, because we found from Gauss's presentation, we said car trips will be replaced by shared mobility more frequently. So we're focusing on how the individual's car emission saving after adopting eHUBs, and all this. This is just an equation of how we calculate this emission saving for the vehicle kilometer travel data and the percentage of mode split we got from the QS2 survey, and the vehicle usage frequency we got from the national statistic of UK and all other published previous studies. Next slide, please. So here's the emission change after adopting eHUBs. As we can see, with eHUBs, the emission will be reduced. For example, for the first figure is Amsterdam. The maximum emission produced without eHUBs around 5 kilograms per day. But after eHUBs, the emission will be reduced to 3 kilograms per day. And next, please. So here's just overall table of how individuals' carbon emission change after adopting eHUBs. As we can see, for all cities, the emission will be reduced with eHUBs compared to without eHUBs. And the maximum reduction was observed from city Amsterdam and Leuven, and well, the smallest for Kempten, but there's a limitation because Kempten only got a sample size 4, which is quite small. And also another limitation is for all cities, the user data is quite small, as Goss already presented in his work. For user data, we got 247, but after we extract the data, only got this sample size with valid car characteristics. So next slide, please. So here is just when we interesting how the individual type of shared mobility can contribute to emission saving. So for user using shared cargo bag produce less emission than shared car and shared bag, but all these types of shared mobility could contribute to emission saving compared to without eHUBs. Next slide, please. So here's just basic some ideas for Manchester case study. So for the left-hand figure, which is reported individuals' carbon emissions, which is calculated based on the reported distance, which we have got from the survey questionnaire and multiplying the emission factor of the type of vehicle. But for the right hand, we are calculating the actual emissions of individuals' car emissions, which is based on the actual distance. We calculated based on the original and destination data from the questionnaire survey data, which is my colleague Matt will give you details how we calculated this distance. Next slide, please. So here's just conclusion of my presentation today. So for non-user survey, as we found participants with the intention to use shared mobility produce a high amount of short journey and annual emissions than participants who are not interested in using shared mobility services. But for user survey, we found participants with experience of using shared mobility services produce less annual emissions than non-users, as shared mobility could help reduce car ownership and individuals' annual vehicle kilometers. So all this can contribute to potentially reduce car transport emissions. And also for all eHUB cities, individuals' car-related daily emission could be saved due to user switch to use shared mobility services. But again, future investigation still requires large sample size to repeat or analyze. Okay, next, thank you. So if you have any questions, I'm happy to answer. Yeah, thank you.
Thank you, Dr. Leila. So again, we will pick up the questions at the end of the presentation. So now I would like to invite Dr. Matthew Burke to the stage.
Thank you. Yeah, I'm Matthew Burke. I'm a PhD student at Newcastle University. I'm relatively new compared to Gus and Leila to the eHUBS project, but I was very interested to see how I could use geographical information systems to enhance the good work that Gus and Leila have already done. So without further ado, am I using this clicker for this somewhere? Yep, so as I said here, I'm primarily talking about GIS within the eHUBS project. And I'm going to split this into two short presentations. The first part, looking at how I can use Gus's findings, identifying areas where there might be the highest propensity to adopt these eHUBs. So just a quick recap, we had the two clusters that Gus identified, the car-dependent families and the multimodal mass-ready people. And again, as Gus has said, it's actually cluster one is probably the individuals that we really should be focusing on. So we've seen parts in previous presentations already that all the eHUB cities are slightly different, but they don't just differ between themselves. Different parts of each city vary a little bit. Take Manchester, for example, or the Greater Manchester area. You've got places like the Northern Quarter, which is the top picture, very trendy, lots of bars, young people probably associate with this place, and then below is a little village called Marple, not far out,
You would expect the demographics to be very different between these two locations. In the UK, we have census information for quite small zones, so we can look at a city in a small zonal area and pick out the key demographics that Gus found in his questionnaire work. So, you know, the age of people, the amount of car ownership we see, people's qualification levels, and whether they have children or not. These are all the things that we want to look at. And then by taking this data with GIS, we can map where they're more or less likely to be. So on this slide here, we can see where the car-dependent families are most likely to be located. So the darker the area represents where they're more likely to be. And I've just highlighted Manchester city centre and Liverpool city centre. There is where there's notably less of them. So it's probably what you would expect. The further out of the city, the more car dependent you become. And maybe when you have a family, you want to move out of the city. And then mapping the demographics of the second cluster, you get actually the complete opposite, where the younger people with no cars and are higher educated are more attracted to the city centres. Perhaps, well, there's generally more professional jobs in the city centres in the UK anyway. And it suits their lifestyle more if you think back to those two pictures I showed earlier. So just to summarise those findings, once we know where these clusters are existing, we could tailor theoretically the provision of the eHUBs accordingly. So, for example, it was, I think, there are more barriers for cluster one, the car-dependent families. They're more reluctant. They might take a bit more persuasion to use these kind of facilities, but we would think that it's worth it because that's where we're going to get the biggest emission savings. Also, they stated that they would they'd be willing to replace their commute trips and their grocery shopping with eHUBs. So again, we can tailor it there, maybe put more cargo bikes or vehicles in these positions. Whereas again, I think even Gus said it, the younger multimodal mass ready people from cluster 2, you could probably more or less, and we know that it would be a city centre thing, you could just put these things in and people will probably just pick them up and go without any persuasion. And they're more likely to use it in the city centre as part of their multimodal trips anyway. So the second part is more to do with Leila's part of the presentation. So how we could use GIS again to calculate trip distances for the emission modelling that you saw some of the histograms earlier. So when I joined, we were looking at a big macroscopic model produced by Saturn for Greater Manchester, which which is useful in its own right, but the issue is it's not tailor-made for short trips, which is they're quite short trips that the eHUBs are targeting. So a lot of the detail was lost between the zones of these on this model. Most of the eHUBs trips were within a zone of this wider model, meaning we just couldn't capture the detail of it. And secondly, at that point, there was no routing through any road network, so we had no idea how far these trips were on the roads. And then, as you saw in those histograms, we did actually have the stated distance that people will make in the questionnaire survey. We asked them how far their trips were, and that comes with some risks because it perhaps isn't the most accurate, which I'll mention later. So yeah, as I said, the solution was to use GIS. You can put OpenStreetMaps into it, and then use this plugin called Open Route Server tool. Basically, route everyone's stated origin to their destination, and then the output you get from that is their precise distance that they've travelled. So the input looks a lot like the picture on the left, where you have the blue is the destinations and the red is the origins. So input that into GIS, and then the output is the purple picture to the right. So within that layer of GIS, all the distance data was we were able to extract it. And this slide really just sort of advertises how beneficial it is. If you look at number 1 on the map there, that's a very short trip that almost certainly would have been lost in the large intrazonal macroscopic size model. In fact, most of the trips were anyway, but that's just an extreme example. And then point 2 is just how important not using straight line distances can be. As you can see, it's quite. I think that is quite a grade segregated road there that person would have to use, but it really highlights how much further the distance would be. And then again, just reminding you of the alternative to use respondent stated distances, because here is the histogram that shows what people said that they were doing in terms of a distance and the actual result as according to the GIS model. I ran just a 2-sample t-test to confirm that there's a significant difference between the two. So on average, people were stating that they were traveling about 4.5 kilometers, and then when we calculate the distances, they were more like 14.5. So if you're putting that into an emission modeling, any output that you're going to get from that is going to be severely skewed. So it just, it's really quite staggering. And going through the actual responses, it looked like a lot of people were saying that they were only traveling 1 mile. I don't know if they either had no idea how far they were or what, or they didn't know quite. It couldn't work it out, but it was just it was way off, and that's why you see so much of the data on the histogram to the left. It's like that huge bar next to the one. I think 1 mile is about 1.6 kilometers, so they're all put in that bin there, and it's definitely skewed the data. So that's the discussion points for that side of my presentation. Is that we really need to think whether we could ever use this kind of data. But fortunately with GIS we overcame that. And I think when I joined, we were just putting together the next survey, I think, and we really highlighted the necessity to get the origin and destination perfect. Otherwise we would run into the same problems with the macro scale model, where we were just sort of routing from one vague area to another, and you don't get precise distances that way. So that's my presentation over.
Thank you, Matthew. So now I would like to invite Gustav, also ask our colleagues to bring again Leila. And if you have questions, please, this is the time. So.
Thanks for your great presentation. I have a question. You used both survey results and actual data, and you mentioned, I guess, during your presentation that you are going to just publish another survey and ask more questions. You found that there is a huge difference between the actual data and the survey data.
Yeah.
And I was wondering how you are going to just deal with it. Isn't it better to just work with more actual data rather than the survey data?
Yeah, probably didn't explain that very well. So the first survey that this was before I started. The first survey that came out. So in the UK we have postcodes which are approximately about 6 digits long, because people we were worried that people were quite reluctant to give up their exact data, where exactly they live and things. We kept it to 4 digits, so it gave you like an approximate area, but they're so big that you were running into the same problem where a lot of people were working and living in the same 4-digit sector, and then as I joined the project, I suggested we should try and get the 6 figure and get the exact actual data. And so, yeah, that is what we've got now. If anything, it's quite an interesting study on its own to see just how much people are unaware of the difference, how far they're actually traveling. But yeah, there would be no point in using the suggested distance going forward.
I have a question for you too,
yeah.
also, Matthew. When you use the ORS for the GIS,
yeah.
Do you consider the different modes of transport that people were, like in the survey, they said the mode of transport that they were using to commute? And then you use that in the plugin, or you just use like the linear distance?
They were all vehicle trips, I think, but or do you mean like if...
yeah, because if someone was traveling by public transport, then the distance would then be like the linear distance of the roads. Then
as in they'd have to get to a bus stop or whatever.
Yeah. And like the route of the bus. Not
on this, but you can do it. And it was something I would really like to do, is just... with the time constraints and stuff, I didn't go into it. But yeah, I don't think it's that plugin. I think there's another one maybe called Travel Time or something like that. And I've run it through, like, just practice goes on it. And yeah, it's actually amazing how it can break up an entire trip like that. So yeah, that would be the ultimate to be able to compare driving using eHUBs and public transport, and comparing all three would be really good. Yeah, thanks.
Thank you very much for the talks. I was wondering whether governments are already involved in your studies and how this would affect their policies. And maybe they're already affecting policies, or how do you see governments progressing from this data?
The short answer is no. They're not involved. But for instance, as a part of the eHUBS project, we were working together with, for instance, Transport for Greater Manchester, who are in control of the public transport. So we have an indirect influence. It depends on how much they use or want to use our findings. And for instance, the research that I presented as part of Amsterdam, we also did in Manchester, and we actually found pretty similar results, even though Amsterdam and Manchester took almost completely different contexts. And yeah, it's really up to them to what extent they want to use our findings, and we try to get our findings, of course, out as widely as possible. And yeah, we hope that they are being picked up. And as Matt has shown, the findings really can be used to plan, for instance, the location of mobility hubs. So there's really great potential to make good use of that data.
We do talk to Greater Manchester, like local government, quite a lot, rather than national.
And can they help you further extend your studies as well, like in a collaboration or something?
Well, yeah, we are collaborating on. It would be, I suppose it would be good to know where they wouldn't be willing to put eHUBs straight away. Otherwise, it'd be pointless identifying an area that just wouldn't work logistically, I suppose.
I thought I will share also my views on that, because we have lots of interest in recent months or from last year from different local authorities from England and Scotland. Recently, ourselves, we represented Polish Leadership Summit in Glasgow, where after our discussions, they approached us asking, would you really want to organize a session so that we can learn, because our city is also wanting eHUBs in the future. So what we are planning to do later in the year, through our ITS UK smart forums, they have a behavioral change forum, and invite all local authorities who are interested to learn from our project. So that is on the plan. So particularly, Gus was working, talking to Edinburgh City Council, and Newcastle City Council is interested as well as so many other councils are interested. So that is the way we are trying to connect the research with practice. So there are some plans on the way.
Are there any more questions? Or?
I work for a city, so we work together. So we use it a lot. I was interested in, because you talk about shared mobility, and I know shared mobility is different modes. Did you put it in the model as well? Because I can imagine, we recently did a survey on moped users, or actually shared moped users, and we found that they use it a lot to go to a station and then take public transport. So the statement that you that in general shared mobility is not used of 3 years to put people out of public transport. What was in this specific case study not true? So can you elaborate a little bit more about that?
Yeah, the first and last mile question is quite interesting. We do know that people definitely use shared vehicles as well as a first and last mile alternative. So that's true. And our survey, we were not really focusing on that. That's something that we intend to do, and we're having an extension of the mobility project, the capitalization call. So that's something we want to dig into deeper, because we know that first last mile is especially important more for the suburban rural regions especially. But yeah, it's not something that came out of our survey directly, but we know it's important, and yeah, that's also a use case definitely. Shared mobility.
It's struggling to get data on that kind of thing is what we've stumbled across quite a lot. Yeah, I heard it earlier in the session. Somebody from e-scooters. 33% of their usage in London, I think it was from, as you said, from a train station or something like that. So it's a significant part of people's user experience.
So if there are no more questions, well, we are very well ahead of time. Still 8 minutes to the end of this session. And, did I see a raise hand somewhere?
Maybe you can tell a little more about what will the future of the study will be.
Yeah, sure. So yeah, currently we're working on the extension of the project, and we're actually still in the process of analyzing the data from the second survey. So we're hoping to to get something out this year at some point. And yeah, of course, we're very interested in the actual emission savings, but obviously we're quite limited in terms of the sample that we have, because as you can imagine, it's quite a challenge to get data from users. Even though we had help from the shared mobility providers, they're really a quite elusive group in a way, so which is surprising because they tend to be very connected, very open to everything. But I think one of the lessons that is starting to emerge from our research as well is that maybe there is not as much potential now to, for instance, reduce car use, but we also have to think ahead. So maybe it's really hard to convince current car users to change, but if we think about future generations, so younger people who are now 18 or less, they are growing up in an environment where shared mobility is becoming increasingly more available. And they're growing up in an environment where the car is not the focus anymore as it has been for us over the past decades. Because as I think someone else earlier this morning mentioned that her daughter said when she was 17 she wanted to get a car. So that is slowly decreasing, I think. And we have to think about these younger generations in particular. And I think it's there where really the great potential lies, because we know that shared mobility is only effective in reducing emissions if it has an effect on car ownership. So if car ownership is not reduced, then it doesn't do much. And I think really the big potential is in those younger people, because they might delay car ownership, or maybe not even get a car at all. And I think that's the ultimate objective with long-term goals of going net zero, because we want those young people preferably not to even get a car. So we have to make it all attractive enough and widely available enough, affordable enough, so that they can say, I don't need a car.
Well, thank you. One last question.
So I was going to ask it privately because I don't know if it interests everyone, but I'm really curious about the GIS part. for someone who's a complete amateur and knows nothing, what are the inputs that you need to create this model? Is it just the origin, destination, and the time of the trip, or how does it work exactly?
Yeah, not even that. You don't even need the time. So what it's really easy to get a grasp of. It's massively recommended. But yeah, you have OpenStreetMaps, which, I mean, before you could do that, you used to have to create the network yourself with like the nodes and the lines. Now you just click, I think it's like 2 buttons, you get the entire OpenStreetMap with every bus stop, timetables associated with it, the road network, and then just as long as you've got the points on the map of where the origin and destination is, a little bit of work, and then you just input the entire data set. And it, as you, I don't know if is it too late to go back with this? Or probably. Might be. Never mind. Worth a try.
Thanks. Yeah.
But yeah, so like those. If you remember the slides with the dots on the map, that's all it was. Just click a button, the purple comes out, tells you the distance. Yeah.
Thanks.
Yeah.
If there are no more questions, I think we can close the session now. So thank you all for joining us today. And don't forget to come down to the second floor. So we have the closing session at 2:45, so in 20 minutes approximately. So thanks again.